out a study last 2014 and asking companies what do you struggle with the most. And interestingly, companies said that variety is something that they struggle with most. Rather than data volume increasing or the data velocity that they use in real time or something, the biggest challenge they face is variety. And let's take a look at how this looks like 20 years ago. We had some database systems on the market, and there was already a challenge to integrate them, to have your dashboards about this data and how do we integrate that. So the data warehouse was used for that, and in the data warehouse, the data is copied into a central repository, and this is done using the ETL process. So it's first extracted from the original sources, and it's transformed into some kind of structure, and then it's loaded into the repository. And the structure is applied on the way, and in the end, the BI users, so the users sitting at the front end, they're using their tools, querying a data mart. So someone sets up a data mart for these users, and they ask their questions to this data mart. Now this sounds all great, but what's the problem with that? We have a high failure rate of these projects according to Gartner. The ETL is a real challenge for them. So the ETL itself is a problem where 50% of the projects fail. We have slow, a long time until you see the first results. So with a huge project, it might take up to 9 months to see the first data on the dashboard. So it's really a huge team involved in that, and it takes a lot of time for this project to run. And of course, when there's many people involved, the whole thing becomes inflexible, of course. And it's very labor intensive to keep this running, and whenever there is a modification, someone wants to see a new thing on the dashboard, we need to modify the whole ETL chain, we need to run the ETL process. So this is a problem with the ETL process itself. Now this is getting dramatic nowadays because additionally to the problems I just spoke of, the variety is just getting dramatic nowadays. So we have more and more services coming up. We have APIs on the market that provide new data, and how to integrate all that. It's of course very cumbersome to do this using the ETL process. And the complexity comes from big data itself developing right now. So we have machine data and unstructured data, social data, all that entering the market, and as well as cloud data. So check out, you can see it here, but it's the marketing technology landscape, and this is only about marketing. There are so many web services that are available, and if you run a marketing department, you might want to integrate them all and ask questions to that, and it's really a tough challenge to integrate all this data. Now a solution to that might be the data lake, because what we do here is we take the data. So you see here quick-stream data, server logs. We do a little bit with it, but we keep the original structure. We put some unique identifier to it. We put some tags on it, and then we drop it into a Hadoop cluster. This is mainly what the data lake is about. It doesn't necessarily mean that a Hadoop cluster can be other technology, but generally it is. So Hadoop is, of course, a very cheap storage, so you can drop a lot of data there. You can take all kinds of data and drop it there, and you don't have this transform part anymore. That used to be a problem with the enterprise data warehouse, because you keep the original structure, just drop it in there. We have already some challenges with that, because it makes no sense to put a database into a data lake, because it's there, it's structured. Why put it in there unstructured, and then for putting it on the dashboard, restructure it? And for web APIs, we have the problem that we cannot get all data from the web service. So if you imagine the Google Analytics web service, you have to put your dimensions in if you query this web service, and then you will get a different result. So for each combination of parameters you pass on to the web API, you will get a different result. And this makes it tough to get all data and put it into the data lake. So let's recapture the data lake here. So the data is integrated by copying it, of course, into the repository. This time we use the ELT process. Now this is a little bit different than the ETL transform and load changed their position. So we extracted from the data source, of course, we put it into the data lake, but when we query it, we need to transform it, because then it's the point where we need the structure of the data. So the data lake itself, putting queries onto a Hadoop cluster, this is something for data scientists rather than BI users. So you either need the data scientists to extract the data and put it somewhere in the data mart, for example, or you need some software that provides a structure for them. So BI users, they query data marts, but they did this before. So that was the thing that they did already in the enterprise data warehouse. So let's recapture the data lake and data warehouse again. Both have physical data integration and both require some effort. So either it's the effort to put the data in, have a structure in the data warehouse, or put a structure on it when getting it out of the data lake. And this means there's no agility, because in the end you put it into some kind of data mart, and BI users, they cannot do new things, they cannot do new combinations of the data. Why do we physically integrate this in those two solutions? We want to query the data with the same language. That means, for example, the BI frontends, most of them speak SQL. So we want to make SQL available to all of these data sources, even though there might be no SQL data sources or web services. We want, of course, to model the data with the same language. So they all need to speak the same language. And we want high performance. For example, if you put this into the repository of an enterprise data warehouse, of course we have a high query performance because we don't rely on the original system to get the data from there. So the logical data warehouse adds something to those both solutions that I just introduced to you. So as a term, it was introduced by Gartner in 2012. And it's called the data management architecture. So it's not necessarily one product, but it can be something that you build on your own using the best technologies for each of the aspects of the logical data warehouse. So it uses repositories just like the enterprise data warehouse. So don't delete your data warehouse yet. It adds distributed processes to that. So we get to a system where we have a repository, where we have something like a data lake, so batch computing able units, so to say. And the third thing that's being added is the virtualization. Now virtualization, it could be an extra speech on virtualization, but let me just quickly define it by teaching a data source a different language. And this is actually what we wanted to do with all the other stuff. We want to create the data with the same language, and using virtualization we can do it. So for our product we put a SQL layer on top of all of the data sources. So no matter if it's a web service, CSV file, or Hadoop cluster, they all speak SQL. And resulting from that, we don't need to physically integrate all data anymore. So we can decide what data to integrate. In terms of structure, it's a little confusing in the beginning, but I'll browse through it. So this is basically the three things I just told you about. Repository, just like the enterprise data warehouse. Here goes your data lake, and then we add virtualization. So this is basically the point where the data sources are, where the data comes from. And on the left-hand side, we have the use cases. Now these use cases are essentially people working in a different way with the same data. So one of them is a BI analyst. They want to see their dashboards appearing in under 30 seconds from data coming from here somewhere. But then we have, for the same data, we have a different use case. We have the machine learning guy, the data scientist, who wants to do batch processing on this data. So he wants to work on this data. It might take some hours to work with that, so that's a completely different use case, but it's the same data. Now all these use cases and their requirements are written down, are somehow punched into the logical data warehouse, and the logical data warehouse takes care of that. So it takes a look. We have someone accessing the data. Now is this the same speed that they want to have the data? Is this the same kind of reply time they get, is their requirement met? Now, if the requirement is not met, they might change to a different way of accessing the data. So if someone wants real-time data, of course, they would use virtualization, because there you get the data from the original data source as it's happening. If they want to do some batch processing, they would use the Hadoop cluster. All of this is surrounded by the metadata layer. So the logical data warehouse is aware of the metadata of all these different data sources. And using this resolution, taxonomy ontology resolution process, it's able to quickly exchange between different ways of accessing the data. So let's wrap it up here. What does it do? Now the logical data warehouse, it knows where the data is stored. Rather than having to get it all, then to replicate it all, or put it into some repository, or put it into a data lake, it just knows where the data is stored, and it can access it immediately. And it combines the three technologies for the use cases like big data processing, classical BI, and agile business analytics, because the users are now able, since all the data sources are virtualized, they can build up their own relations. Now they don't have to rely on the structure that the data scientists provided for them in the repository on the data model, but they can make up their own connections between data, and this enables self-service BI. Now the advantages are, we have real-time data, so as soon as the data source is connected, we can get data from it, and this data doesn't go through the ETL chain, therefore it's there immediately. And it's immediately productive, because as soon as it's connected, you can work with it. We use a logical data model on the LDW, because we don't define the structure physically, but we can define it logically. So think about this as being a view where you state the connections between the data, or for example, you rename some columns, but this is not a materialized view. So this gets executed as soon as the user is accessing it. Now we add permissions and governance to the model that we had before, because for the data lake, essentially there is no permission concept there. It needs to be applied from an external source. For APIs and web services, we also virtualize them, and that means it's possible to use SQL as a language to query them, and therefore it's possible to even query them from the BI frontend, such as Tableau or Excel or Looker. And another advantage is, of course, that the business layer and the tech layer, they are decoupled. Since we work with a logical, flexible data model, we have our own business layer that defines our data model, but it's completely set apart from the tech layer, because the tech layer would be the physical integration where you define the structure in the repository. Now let's take a look at the technology map here. We have actually 3 dimensions. We have the performance, so the more we go up, we have more performance. We have agility, that means being able to change to new models, to new questions that business users might ask. And we have, as a color, we have the implementation maintenance. Now, there goes the self-service, self-developed BI. We assume that it doesn't have a high performance. It's actually what you need, but it's hard to maintain it. So it's red because it has a high maintenance effort to use it. And up there we have the enterprise data warehouse, which of course has high performance because it's using the repository. And it's the least agility because every time you want to modify something, you need to restructure the whole thing. The data lake is looking very good already, so it's got high performance and it's a little bit more agile. But we see that using the virtualization and BI users being able to make their own connection between data sources has the highest agility. So it's got the same performance because it uses the data lake as well. So if you need performance, it uses the repository, but it adds virtualization, and this is why the agility is so high. And since you can start immediately with it, the implementation and maintenance effort is not that high. Okay, for data federation, this would essentially mean, this is also a big topic on the market right now, and this would mean only using virtualization without the repository and without the batch processing engine. So this is, of course, has the same agility, but it's a little hard. It has no high performance because it's not using the speed layer as a repository, for example. And of course, we have a little more to do here with implementation and maintenance because we need to know the structure of the data sources and how to efficiently do the distributed queries. Okay, so conclusion. We think the logical data warehouse holds enormous promise for the future and will be the next big thing for companies. Well, there are different use cases supported for big data use cases that are coming up now and classical BI use cases. And of course, we have flexibility and real-time access that gives the business one advantage. And we say that explore, use, optimize. That means I can explore the data. So I can use my BI frontend to play around and get data from different data sources, use them, and then we see how can we optimize it. So can we change to a repository? Can we change to batch processing? Or can we use virtualization and real-time to optimize the query performance here? Instead of the classical approach, which was build it, test it, and then use it, and if something changes, well, you have to go through the whole process again. So every time something has to be changed, you need to go through the process again. But here you can just use it, and by using it, you define how the data is accessed. So the Explore, Use, Optimize provides a quicker time to solution, and the heart is dropping, but it should be there. So we love Data Economy. Thank you for making this possible. Thank you also for the organizer, for the host of this event. And that's my speech, and thanks for your attention.
I wanted to ask about the situation on the market now. Do you already do some implementations, or how is this going? I mean, I worked for quite a few years in regular BI implementations, and while I agree on all the disadvantages of BI that you mentioned, on the other hand,
you need to add maybe 2 more years to get the software running. So we're effectively on the market for 1 year now. And we have customers from North, South America, Europe, Australia, big companies. So it's DHL is our biggest customer. So they really see that they can leverage this. But I agree completely to you. I always, when I do the proof of concept and sit in the companies, I have this Oracle BI guy sitting there in front of you. They are, but exactly. Cross your arms. Because, yes, they resist, of course. They want to resist because they say, well, everything that you do here, putting data on the dashboard in the end, we can do it as well. But the same people told them, okay, but you need 2 weeks to add a new field. And with the logical data warehouse, you just rescan the data source and then the data is available. So definitely we need to do some work, and this is why we're doing this speech, to get the word about the logical data warehouse to the people, to share the knowledge about this.
Thank you.
I have a question. I don't know if you can answer it in 2 minutes. If not, then skip it. Usually you create a data warehouse so that you can access easier aggregated data.
Mm-hmm.
Okay. So, but here you said you don't have this ETL process. You get real time. You have access to the data, but at the same time, it's very high performing. So I don't understand how you achieve this. Usually you do exactly. You say, okay, you create some cubes. So you don't have it takes some time until you have the cubes, but then all the aggregated data, you get it faster.
That's right.
But I don't know. Can you maybe explain how you manage this? How you use cache or something?
In our own software, this is basically what we do here. Users want to access their data, and they have their use case, and this use case means, of course, also accessing aggregated data. And for that, we even build some kind of ETL chain. so it's still there. So the repository was never gone. So the traditional data warehouse is still in there, but people might want to use real-time data. So they want to have data that's happening right now, and this is never available with that, because basically you calculate the cubes at night. So what we could do there is still have those pre-calculated aggregations. So we call it optimizing in our software, so that you can right mouse click on it and say optimize, and it will automatically build the ETL chain and download this and aggregate it. But you can also add this layer to it. So what you could do is a union between repository data and get the real-time data from today using a web service, doing a union of that and giving this data to the front end. So this would be, for example, the speed layer, where we don't have to wait for the ETL chain to necessarily run right now to get our newest data, but we use historical data from the repository and current data using virtualization. So this might be one way of speeding this up. And of course, the repository is still there, so we rely on an analytical database. That can be Postgres, or it can also be Amazon Redshift or XSO. So we have some high-performance analytical databases under the hood, and we can exchange them. So you can scale with these databases. And this is also one thing about big data technology, that those in-memory databases and columnar databases such as Redshift and XSO are really performing well, and you don't necessarily need the cubes anymore.
Time for one more question. I saw at a certain point someone had a question.
Do you have a limit on the variety of data?
Well, actually, on the variety, there's not so much a limit. If you want, of course, if you take a look at virtualization on its own, of course, there is a limit what you can do in terms of the size of the data. So, of course, you cannot do a real-time join between 100 million and 100 million rows of disparate data sources and expect this to appear on your dashboard immediately.
What about columns?
About columns, there's memory is the limit. So I'm daily using tables with 600 columns and some 10 million rows, and this is.
What about 100,000 columns?
The point is here that we use standard ways of accessing that. We call it push down. So we push down the query to the database and get the result back. So we're essentially, for the standard databases, we're just using their JDBC interfaces. And what we do is, whenever a distributed query is coming, then it gets interesting for us, because we need to do something in memory to join this, of course. This is where it gets complicated, but I'm not aware of those limits, because as long as the database can handle this, we can handle this as well. All right.
Thank you very much, Matthias.